Okay, so I'm back. I am going to work through this check your understanding for lesson 9-7, just because there are a couple of things that we have added on here that you might want some confirmation on as you're working through this. So problem 1 says, students at a small high school in Michigan were asked, which subject area do you prefer, math or English? For each student, their grade level and response were recorded. Okay, so we have freshmen, sophomores, juniors, seniors, whether you like math or English. We have totals going along the bottom and along the side. And to me, it looks like a total then of 250 students in all were surveyed. Okay, so A says, if a student is randomly selected, what percentage is a senior who prefers math? What percentage is a senior who prefers math? So if a student is randomly selected, so of all the students, I'm looking for one who is a senior and prefers math. So that's 40 students out of the 250 that are surveyed. So that's 0.16, which percentage-wise would be 16%. Okay. B says from the set of students, so the whole set of students who prefer math. Okay, so from the set of students who prefer math, I'm looking specifically at this math row here. What percentage of these students are freshmen? So I have 20 freshmen. But see, I'm not looking at all the students because it says from the set who prefer math. So this time I'm doing a total out of 119. And so when I divide that, I get 0.168, which would round to 17%. Okay. And then C says, if only freshman students are considered. I'm going to switch my color here. So now only freshman students are considered. Means I'm looking at only this column. What percentage of these students prefer math? So again, still a 20. But this time it's out of 64 because there are 64 freshmen, and that's the only group I'm considering this time. And so when I divide, I get 0.313, which would then be rounding down to 31%. Okay, so you just have to pay attention to what group you're looking at, whether it's the entirety of the population or whether you're looking at a subpopulation or a subgroup of people to know what that denominator is going to be. Let's take a look at question 2. So question 2 was actually once a state test question on the state algebra test. So you get a peek at what has been asked before. It says, Leroy asked 133 juniors and seniors at his school whether they drive to school or ride the bus. Use his conclusions to complete the table. Okay, so there are 38 juniors that ride the bus. There are 7 more juniors than seniors, and exactly 2/3 of the seniors drive to school. And they already filled in the total, right? We have a total of 133, so that's right here. And 38 juniors ride the bus, and so they put that right here. You get to fill out the rest of the table. Okay, there are 7 more juniors than seniors. Okay, so between the 38, that means that, for example, I would have to pick numbers like, so 14, if I had, let's say I had, so I have 133 in total, right? So let's say that I had 100 seniors, then that means that there would be 107 juniors. But that can't be right because that total would be 207, but I have a total of 133. So my point is this. My point is I could try to guess what this is going to be. If I'm going to just do a guess, notice I'm labeling. If there are 7 more juniors than seniors, then my guess is 100 seniors. I'd have to have 7 more juniors. Whatever that guess is, your total has to add up to 133. So you can play this game of guess and check. Or we can just label J for juniors and S for seniors. And we can say, okay, well, my seniors, whatever my seniors are, I would have to add 7 to that in order to get my number of juniors. I can make an equation. Or like I said, I can guess and check. Okay, so I can make that equation. At the same time, remember, these two things both have to add up. Whatever 2 numbers I choose has to add up to 133. So I could say seniors plus juniors has to equal 133. So again, whether you guess and check, these are the rules that I have to live by. Whatever number I pick for seniors, I have to add 7 to get juniors. And the 2 numbers that I pick have to total 133. So if you're going to guess and check, then these are the rules we live by. If you don't want to guess and check, then we can do a substitution, right? Look, I have j is equal to s plus 7. And so in this equation, I can replace the j with s plus 7. So I really have s plus juniors, which is seniors plus 7 more, equals 133. And then I can actually just start solving this equation, right? I have two s's. I'm going to subtract 7 from both sides. So 2 s's is equal to 126. And if I divide by 2, if I divide by 2 on both sides, I'm going to get that there are 63 seniors. Again, you can guess and check, but these are the rules I live by for guess and checking. That I have to add up to 133 and that I have 7 more juniors. So to get my juniors, I'm going to take that 63 seniors plus 7 and get 70 juniors. Again, you could have guessed and checked. But this is what I come up with. So I have a total of 63 seniors. That 63 is going to go here. And a total of 70 juniors. That 70 is going to go here. And those two numbers add to 133. So this is helpful now. This is helpful because now I can start building in some numbers, right? Like I can figure out what this number is by doing 70 minus 38. And 70 minus 38 is 32. So I can at least get that number in there. All right, the other thing they tell me is that exactly 2/3 of the seniors drive to school. Well, now that I know that there are 63 seniors, I can do 2/3 of 63. And when I do that, I get 42. So I'm looking at seniors who drive to school. That number is 42. Okay, and now I can just finish filling pieces in, right? 32 plus 42 is 74. If this has to add to another number to get me 133, 74 plus 59. I'm just going to subtract 74 from 133. So 74 plus 59 gets me 133. And then I can get this remaining box a couple of ways, right? I can either do 59 minus 38, or I can do 63 minus 42. In either case, I should get 21 inside my box filled in. So I wanted to talk about this one because, again, I have this idea of guessing and checking, and students can be successful with guessing and checking. But I still have to live by these rules that I created algebraically. Seniors plus 7 gives me the juniors, and combined, they have to add up to 133. So you can guess and check, or you can use algebra to solve. All right, let's talk about 3. 3 was also a released test question. This was on the state test at one point. So let's read through it. It says, the employees at a company were asked if they are married and if they have children. The results are shown below. Okay, so they don't have any totals for me is what I noticed. We'll see if that matters. It says, what % of employees are married and have children? So what % of employees, I'm looking at all of them, are married and have children? So I'm looking at a yes, yes. 30. But a % is when you take 30 divided by a total. So I need to fill out some totals here. That is what is missing from my table. So I'm going to extend my table here. And I'm going to fill in my table, right? So 30 plus 21 is 51. And 18 plus 6 is 24. So that gives me 75. Going down the column, 30 plus 18 is 48. 21 plus 6 is 27. And if I add that way, I also get 75. Okay, so what % of the employees? I'm looking at all the employees. There were 75 employees in total. Are married and have children. That's yes to both, so 30. And so when I divide those, I get 0.4 or 40%. B says, what % of the married employees? Okay, let's take a look. What % of the married employees? So that's going to be my denominator now. So married employees, that's yes. Looking at this column here. And that column is out of 48. So what % of the married employees also have children? So I'm looking at a yes to children out of the whole group that's married. So 30 out of 48, which is 0.625 or about 63%. Okay. And then C says, what % of employees with no children? So here's my condition. What percentage of employees with no children? So that means that I'm looking at this row here. So my total is out of 24. Are also not married. So I'm looking at a no-no. I'm looking at 6 out of 24, which is 0.25 or 25%. Okay. So again, in this case, we had to build the totals area or sections in order to answer these questions. And so again, if you have any questions on these, let me know. The next thing you'll be working on is the practice, so you can try some of these on your own.